Welcome to New Star. Hello, worldo. Yahoo! This is your hacker Neko Rival Cyan. Welcome to the stream. Hello, highly intelligent Owen. Hello, Jupiter. Hello, Tushi. Hello, Lloyd. Hello, Mr. Lucas. Hello, Burning Star. Welcome. Hello, Badger. Hello. Hello, Sancrest. Hello, 沈老师，欢迎。Welcome, Sanitas. Welcome, Batomi. Do I look smart today? Thank you. 冰猫早上好。Welcome, Andel. Welcome, 有力气。Welcome, Frank. Welcome, Mohammed. Welcome, late as usual. Hello. Hello. Today, we are continuing to tackle the problem of lifetimes. And if we finish this long chunk of chapter, we're going to move back to error handling because I haven't covered that yet. Before, we went over generics and the trait, which are really awesome stuffs that makes Rust powerful. So today we're learning about lifetimes. To understand how long each variable survives. It's like one of the hardest concepts in Rust. So are you ready? Let's have fun together. Welcome, Mako. Konbanwa. Or Ohayo. 大家都早，欢迎。よし、行きましょう。Let's read about this. What is validating references with lifetimes? What is references? What is lifetimes? One detail we didn't discuss in the reference and borrowing section in chapter 4 is that every reference in Rust has a lifetime. Every reference has a lifetime, which is the scope for which that reference is valid. Most of the time, lifetimes are implicit and inferred, just like most of the time types are inferred. Oh, so most of the time you don't have to explicitly declare it. It is inferred by the compiler. We must annotate types when multiple types are possible. In a similar way, we must annotate lifetimes when the lifetimes of the reference could be related in different ways. So we are going to annotate lifetimes when there's multiple ways to infer them. Rust requires us to annotate the relationships using generic lifetime parameter to ensure that the actual references used at runtime will definitely be valid. Okay, it's like usual Rust. It wants us to do the stuff to make sure the stuff we run is correct. I like this compiler. Welcome, Watcha. Hello. Annotating lifetimes is not even a concept in most other programming languages, so it's going to feel a bit unfamiliar. Although we won't cover lifetimes in their entirety in this chapter, we'll discuss common ways you might encounter lifetime syntax so you can get introduced to the concept. Oh, I feel pretty new to this. So why do we need lifetimes? Because we want to prevent dangling references, is it? The main aim of lifetimes is to prevent dangling references, which cause a program to reference data other than the data it's intended to reference. Consider this program, which has an outer scope and an inner scope. I think we have done this last time, but we can do a little review. Hello Slayer, welcome! Welcome Kilo Deja! Pivot! Welcome Yolitin, hello! Okay, so why does this not run? We declare R in the outer scope, and then in the inner scope, we declare X and set R equals to the reference of X, and then we print it. But we have a confused crab here. A confused crab, why is that? It is because the scope of X is inside of the inner scope. So in the outer scope, X has been dropped, and the reference to X is gone. Is it why? The examples in those declare variables without giving them an initial value. So variable name exists in the outer scope. Oh, this is a sign note saying that this is valid. Even though Rust needs to have Rust doesn't have no values, but if we try to use a value before giving it a value, we'll get a compile time error, which shows that Rust indeed does not allow new values. So as long as, even though this doesn't have a value, but we don't use it, so it'll be fine. The outer scope declares a variable R with no initial value. It flies. And the inner scope declares a variable X with initial value of 5. Inside the inner scope, we'll attempt to set the value of R as a reference to X. And then the inner scope ends, and as we try to print the value in R, X has gone out of scope. So it doesn't work. So the error message is X doesn't live long enough. Poor baby. You just dies before I use you. Welcome Eric, welcome MacBrad, welcome Sebastian, welcome Denise. Hello. Will you guys live longer than me? Do you guys need a lifetime that's as same as Cyan? I'm forever 18. But I'm just a little confused. Does a lifetime make other things live longer? Or it is just an indicator? It's just a relationship. Let's find out. So yeah, this is all about that X will be out of scope, but R is still valid. R lives longer. If Rust allowed this code to work, R would be referencing memory that was deallocated when X went out of scope, and everything we tried to do with R wouldn't work correctly. So how does Rust determine that the code is valid? It uses a borrow checker. What is a borrow checker? The Rust compiler has a borrow checker that compares scopes to determine whether all the borrows are valid. So their annotation for lifetimes. The lifetime of R is this big scope, and lifetime of X is this small scope. Small scope. And then this code fixes the code so it doesn't have dangling reference. The scope of X is this entire scope by this B. And the scope of R is when we first declare it and last use it. And X, since it is valid for the entire scope, we can use it anywhere inside the scope. So if we do that X equals to 5, that R equals to reference of X, print line R, and this value, save and cargo run. It will keep the value of X. Now you know that where lifetimes of reference are and how Rust analyzes lifetime to ensure reference will always be valid. Let's explore the generic lifetimes of parameters and return values in the context of functions. Let's explore the generic lifetimes of parameters and return values in the context of functions. Ooh! Generic lifetimes in functions. Let's write a function that returns the longer two of the string slices. This function will take two string slices and return a string slice. After we have implemented the longest function, the code should print the longest string is ABCD. So let's write it. Before I write it, let's read the chat. What's the point in using lifetime? It prevents memory leaks and other stuff that C++ already has. Lifetimes are very important to avoid memory leaks and accidentally referencing memory address that are no longer valid or saved to reference. Just like the X example. If the X is in a scope, like this, when we free X, it's gonna be a dangling pointer. R would be a dangling pointer. So Rust would prevent us from doing that. So if I do caco around now. Oh, R needs a type. Was it a hint? Wait, what? Okay, it's infer type. Okay. And wrong. Yep, the compiler doesn't like it. Because X didn't leave enough. Just so you know, if you don't correct the lifetime, Varys will come knocking at your door and fight you. Kill Varys. Yeah, we could just write this. I just realized today, if you have a instance and you're trying to get it filled by using the dot, you cannot do it. You can only put entire variable names. Oh, well, this doesn't work, but this is how you do the shorthand. Varys got a pinch of death. Bunk. Bunk, welcome Evan. Okay, where are we? We're trying to write the longest function, so let's do it. Let string 1 equals big string from ABCD. It's a little hard to see. Is it? It's a little hard to see. Whoosh. And then let string 2, is that string slice? Equals to XYZ. It's a string slice. And we're trying to find which one's longer. Is there a longest function? They haven't implemented the longest function yet, but we can just use it. We can pretend we have it. Here we change the big string to a string slice. And then we will print the result. Like this. Please don't use the lifetime parameter, it will drive you crazy. Oh my god. Well, I guess that's what we have to do. Okay, we haven't defined the longest yet. So how will we define it? It's a little sad this doesn't fit in. I mean... it wouldn't fit in. It wouldn't fit in. I guess this is about right. That's a conspiracy. Okay. Then it goes to implement the longest function. It takes the string slices, which are references. So first they implement it like this. Function longest x, which is a string slice, and y, which is another string slice, and it will return. It returns a string slice. And if x length is larger than y's length, then we return x. Oh, I'm writing Python. Gosh, I barely code. And else, we return y. But this won't work. It's saying missing lifetime specifier. This function's return type contains a borrowed value, but the signature does not say whether it's borrowed from x or y. What's going on? If we run this to see, it's like pointing out, consider introducing a named lifetime parameter. Because we expected a named lifetime parameter. So for a longer explanation, it's saying the return type needs a generic lifetime parameter on it, because Rust can't tell whether the reference being returned refers to x or y. So we do not know which one will be returned, because it really depends on the input. When we are defining this function, we don't know the concrete value that will be passed in this function, so we don't know whether the if case or the else case will be executed. We also do not know the concrete lifetimes of the references that will be passed in, so we can look at the scopes as we did in our example to determine whether the reference we return will always be valid. We're trying to make sure that the reference we return will always be valid. The borrow checker can't determine this either because it doesn't know how the lifetimes of x and y relate to the output. To fix this error, we'll add generic lifetime parameters that define the relationship between the references so the borrow checker can perform its analysis. So we need to add genetic lifetime. You're getting fierce flashbacks to moments you argued with the lifetime checker a few years ago for the capstone project. Oh wow, what did you do for your capstone project? I was looking into the video I'm looking at what kind of jobs does a Rust programmer get. It looks like it's like low-level blockchain infrastructure stuff. That looks super complicated, like distributed system and stuff. Are you guys in those industry? In those field? Lifetime annotation syntax. Lifetime annotations don't change how long any of the references live. It doesn't actually change how long the references live. It is just an annotation. Just as functions can accept any type when signatures specify a generic type parameter, functions can accept references with any lifetime by specifying a generic lifetime parameter. Lifetime annotation describes the relationships of the lifetimes of multiple references to each other without affecting the lifetimes. So it doesn't affect the lifetime at all. It's just clarifying the relationship, telling the compiler, hey, this is a relationship. And just follow it. It can technically run as in the lifetime parameter for you for most case. Is it like what the borrow checker do? Hello Tue, welcome! Good afternoon. Okay, so how do we write lifetime annotations? It uses a apostrophe. Use an apostrophe. And we can name the lifetime using whatever we like. I was looking at my stream title. It says Tika. But it doesn't have to be Tika. It doesn't have to be Last time I was like and everybody is like and my stream stopped because of the internet. But it wasn't until today I realized I can name anything for the lifetime parameter. And they're usually lowercase and very short. But it doesn't have to be even though most people use Okay, we place lifetime parameter annotation after an ampersand reference. We put it after the reference, just like where we put mute, using a space to separate the annotation from the reference type. So we put the tick. Gosh, is that a tick? What is it? Is that a tick? Is that a tick? It looks like a tick. This is the symbol, right? It looks like it. Let me copy paste just to verify. Okay. It's a part of the small, how do you say it? It's almost like what you use for a character. Single quote, yes, single quote. I was looking at the thing on the escape button, the little dot, and I was like, wait, that's not it. That's a single quote. Like, what we need is a single quote. We don't need the strange little dot on the escape button. Hello, welcome, hello, and welcome on the score. So this is how you add a lifetime annotation. Like this. And this. And if we want to put multiple, we put it between the type and annotations. One live annotation by itself doesn't have much meaning because the annotations are meant to tell Rust how generic lifetime parameters of multiple references relate to each other. So we don't usually give it one lifetime annotation. It appears in group, just like some Pokemons. Wild animals, they appear in groups because this exists to tell how the lifetime relates to each other for the compiler. Let's say we have a function with parameter first that's a reference to integer with a lifetime of Tika. The function also has another parameter named second that's another reference to an Tika. Wait, another reference to an integer that also has the lifetime Tika. The lifetime annotations indicate that the reference first and second must both live as long as the generic lifetime. So if we have lifetimes here and there, Oh, it's undeclared. Why is it undeclared? We probably need to add something else. But if we use it there, we're saying the X, Y, and the output all have the same lifetime. And to declare it, looks like we need to use this sharp braces, angle braces, put it after the name of the function. We need to declare generic lifetime parameter inside the angle brackets between the function name and the parameter list. So right here, when you declare it here, remember, the constraint we want to express in the signature is that the lifetimes of both parameter and lifetime of the return reference are related such that the return reference will be valid as long as both the parameters are. So we are saying all of them will have the same amount of validation time. We'll name the lifetime tika and then add it to each reference. Like this. Is there anything wrong with it? Well, compiler seems to like it. That code should compile and produce the result we want when we use it with the main function. It does? It does? Let's see. Agora. Ooh, it's saying the longest string is ABCD. It works. It works by telling the compiler that the input and output has the same lifetime. Or what exactly does it do? The function signature now tells us that for some lifetime tika, the function takes two parameters, both of which are string slices that live at least as long as lifetime tika. The function signature also tells Rust that the string slice returned from the function will live at least as long as the lifetime tika. In practice, it means that the lifetime of the reference returned by the longest function is the same as the smaller of the lifetimes of the reference passed in. The lifetime of a reference returned by the longest function is the same as the smaller of lifetimes of the reference passed in. So it's saying the return as the smaller one of the lifetime. These relationships are what we want Rust to use when analyzing this code. Remember, when we specify the lifetime parameters in this function signature, we're not changing lifetimes of any value passed in or returned. So we're not changing anything at all. We're just specifying that the borrow checker should reject any values that don't adhere to these constraints. Note that the longest function doesn't need to know how exactly the x and y will live, only that some scope can be substituted for tika that will satisfy this signature. Wait, what? It's not tika? It's not tika? I don't know what's the name. It's cute. Tika. Wait, let me read this again. When we specify the lifetime parameters in this function, we're not changing the lifetimes. Yes, I get that. So, we're just labeling it for a compiler to understand. Rather, we're specifying that the borrow checker should reject any value that doesn't adhere to the constraint. Okay. So we're telling the borrow checker if something doesn't. Wait, what? We're specifying that the borrow checker should reject any values that don't adhere to those constraints. So those lifetimes are actually constraints. Note that the longest function doesn't need to know how exactly long x and y will live, only that some scope can be substituted for tika that will satisfy this signature. I feel like a cat in the universe. What does this mean? Happy New Year, 晚上好，欢迎。Tika is great. Okay. I hope I don't make fun of myself one day. You're meeting everybody listening about Tika and they're like, what's it, Tika? You don't really get to practice the lifetimes of tongue in practice? Do they just get used in scenarios like this? Lifetime label scopes. Scopes can be thought of as brackets. How do you label scope? Or we're saying that all x, y, and return has the same scope. And if somebody runs out of scope, then compiler will complain of problem. The lifetimes label which set of brackets your variable is controlled by. It's generic. It applies to whatever you pass in. The problem is that the compiler can infer lifetime 90% of the time, which is a good thing. They are annoying to deal with, but once you do actually have to deal with them, it's annoying. Oh, but this is one time. It doesn't infer. It means that for as long as the reference returned from longest lives, the two input reference they borrowed. As long as the reference from the longest lives, the two input reference they borrowed. Let me finish reading the paragraph. Maybe I'll get a better idea. When annotating lifetimes in functions, the annotation goes in the function signature, not in the function body. Okay, it goes in the function signature. The lifetime annotation becomes part of the contract of function, much like the types in the signature are. Having function signature contain the lifetime contract means that the analysis the Rust comparator does can be simpler. If there is a problem with the way a function is annotated or the way it is called, the compiler arrows can point to the part of your code and the constraint more precisely. If instead the Rust compiler made more inferences about what we intended the relationships of the lifetimes to be, the compiler might only be able to point to a use of your code many steps away from the cause of the problem. So it is for compiler to easily identify your problem, the root cause of your problem. Lifetime Tika has to be at least as long as B. Tika B, if you could return either of them. Otherwise, you may end up with a case where you return B and try to use it somewhere else, but you already got dropped. Usually you use struct lifetimes to annotate strings, I think. Oh, that's where you usually use. In function signatures, lifetimes are never inferred in any particular smart way. Instead, there are so-called lifetime elation rules, which are deliberately straightforward to ensure stable APIs. Will you talk about it later? Elation. Oh, it is. We will. Okay, it's a long chapter. Where are we? Got lost. I think we're here. We're adding this to the function signature. So it sounds like this TKA is like the minimum of the inputs and the output. The lifetime of a reference returned by a longest function is the same as the smaller of the lifetimes of the reference passed in. When we specify the lifetime parameter in this function, we are not changing the lifetimes of any values. We are specifying that the borrow checker should reject any values that don't adhere to constraints. Note that the longest function doesn't need to know exactly how long x and y will live, only that some scope can be substituted for TKA that will satisfy this signature. So this is explaining why it's all in the function signature. Because it's a construct. It's a contract. It's a contract that we want the compiler to check for. Thank you, Sanitas. Have a good one. Have a good day. Thank you for visiting. When we passed concrete reference to longest, the concrete lifetime that is substituted for TKA is the part of the scope of X that overlaps with the scope of Y. Oh, so this TKA is the scope that overlaps between X and Y. It's like a Venn diagram, and in the middle is that valid scope. In other words, the generic lifetime TK will get the concrete lifetime that's equal to the smaller of the lifetimes of X and Y. Because we have annotated the return reference with the same lifetime parameter TK, the return reference will also be valid for the length of the smaller of the lifetimes X and Y. It makes more sense. It makes a little more sense. Let's look back at how lifetime annotation restricts the longest function by passing reference that has different concrete lifetimes. So what happens in this? This is why the book talks about at least as long as A. Tika A. Tika. This is why the book talks about at least as long as Tika. The original lifetime of the reference you pass to longest can have a longer lifetime than the lifetime Tika of returned reference. So the original argument can have longer lifetime than Tika. We don't change the lifetime of X and Y, but we give a construct to the output. Tika A reference string this means that it remains valid for at least Tika A. References can change type, their lifetime can become smaller. References can change type, their lifetime can become smaller. References can change type, their lifetime can become smaller. It's what does references can change type mean? On input arguments, there's a demand, and on return value is a promise you make. We're talking about promise? So on the return value, we're promising this thing can leave this Tika. Technically, references can change type. Their lifetime can become smaller. Oh, so what? So the lifetime is a part of type too? And we can change a longer lifetime. We can change the annotation of a longer lifetime to a shorter lifetime. Is that what it means? Oh, this is brain twisting. The value can be converted. Yeah, I feel like we have unlocked a door of forbidden knowledge. Converting the lifetime of a reference to a smaller lifetime is known as reborrowing. What? What? What's the use of making the lifetime shorter? Variance? Variance? What? What have I gotten into? Oh, chat is going wild. I'm staying awake. Just kidding. Thank you. Thank you for teaching it. Thank you for teaching it. I watched a video before I start this tutorial. Still learn so much from all of you. so many new things to learn. Welcome, Ransan. Hello, how are you doing? Okay, where are we? We are in this example. Are we? How the lifetime annotation restrict the longest function by passing in reference that have different concrete lifetimes. Okay, so what's going on? Oh, so here we have string 1 in the outer scope, and then we are moving string 2 to the inner scope. Is that what's happening? In this example, string 1 is valid until the end of the outer scope. String 2 is valid until the end of the inner scope. Run this code and you'll see the burrow checker approves this code. It will compile and print the longest string is long string is long. Why does it change to long string is long? Well, the longer string is the one on the outer scope. Next, let's try an example that shows that the lifetime of a reference in the result must be smaller lifetime of the two arguments. The lifetime of the reference in the result must be the smaller lifetime of the two arguments. Ugh. Okay. So here we have let result. And we define a string result equals to why do we need to have the big strings? So what are they trying to do here? We have a string 1 with a scope of huge spixing and the result of this scope, and string 2 in the inner scope. Oh, and we try to access string 2. We're trying to have the output in the outer scope. So what will happen is that because Theta A will be the smaller scope, which is in the inner scope. So if we want to access the output in the outer scope, it won't work. Let's see the error message. Actually, I can see it from here. It says it doesn't live long enough. The string 2 doesn't live long enough. Hello, Maria-san, welcome. So, what's gonna happen? It says string 2 doesn't live long enough. Let's borrow here. It shows that for result to be valid for this print lane, string 2 needs to be valid until the end of the outer scope. Rust knows this because we annotated lifetimes of a function parameter and returned values using the same lifetime parameter tika. Thank you for the super chat, Warrior-san. Arigato! Arigato! Good luck in your work! For result to be valid for the print line statement, the string 2 needs to be valid for the entire outer scope. Rust knows this because we annotated lifetimes of this function parameter. And the return values is the same lifetime parameter tika. So Rust is complaining about it. Yay! It's saying that as human we can know that string 1 would be valid for print line. And even though, another point is trying to prove that this is the longer string. As a human, we can see it doesn't even go to this white case. But still, the compiler cannot do that. So we need to tell the compiler the ticker, the exact time. Try designing more experiments that vary the values and lifetimes of the reference passing the longest function and how the return reference is used. Make hypotheses about whether or not your experiment will pass the borrow checkup before you compile, then check if that's right. So if we put the string 2 outside, I'm pretty sure if I declare the result here, what would happen? It would not be able to find the scope. Whoa, wrong button. But this should work. Should it? Although there's no point of putting the result in here. Yep, it's returning the right value. It's returning the longer one. Okay, thinking in terms of lifetimes. The way in which you need to specify lifetime parameter depends on what your function is doing. For example, if we change the implementation of the longest function to always return the first parameter rather than the longest string slice, we wouldn't need to specify a lifetime on the y parameter. I also put the thing in a scope. Like this. I can put a part of an expression into a scope. Can I? What does it give me? It should still give me the right answer. Oh, I can directly use the reference? People know so many shorthands. Oh, worked. Now we don't need to use as string. Block doesn't need any statement at all besides the final return expression. Oh, do people actually use block? A lot of blocks? Oh, it's hard to see, but I put that little semicolon. So I call them at the end of the brackets. Ooh. Ooh. Okay. And here it is saying if we do not mess with y at all, we just directly return x. I'm still amazed it doesn't need to write return to return x. We don't need the ticker for the y because we're not using it. It's like a warning. Why won't you use me? Okay. The lifetime of y doesn't have relationship with x or the return value. Oh, okay. There's so many brackets and but you don't make something equal to a bracket a lot often. Okay, moving on. When returning a reference from a function, the lifetime parameter for return type needs to match the lifetime parameter for one of the parameters. When returning a reference from a function, the lifetime parameter for the return type needs to match the lifetime parameter for one of the parameters. So many parameters. If the reference returned does not refer to one of the parameters, it must refer to a value created within its function, which would be a dangling reference because the value will go out of scope at the end of the function. What does it say? When returning a reference from a function, okay, the lifetime parameter for the return type needs to match the lifetime parameter for one of the parameters. So this return type needs to reach lifetime parameter of either of those. If the reference return does not refer to one of the parameter, okay, it must refer to a value created within this function, which will be dangling reference because the value will go out of scope at the end of the function. But that would be bad. So what happened here? What happened here? So here we have our generic lifetime. We have x without tika. We have y without tika, and we have a tika. And let result equals to string from really long string. And we return result as string, and it says no. No. Why is it no? It's a mismatched type. Huh? Mismatched type? Why is it mismatched? Oh, it's a reference. Bakami. Okay, slightly. Still wrong. Let's see what the console says. Hydration's check, thank you. Let me drink some water. Everybody drink water. Welcome, Aquas. Hello. Okay, what's going on? Expected a lifetime parameter. Wait, what? Wait, what did I just do? What did I just do? I double up the reference? What's going on, Cyan? Your brain is okay? Is your brain okay? Ohayo gozaimasu. What did you find? This is not a what? I had a semicolon. And now it doesn't like this. Oh, finally the same arrow. I'm reproducing it. Returns a reference to data owned by current function. Oh, we return something in this function. And this thing will be dropped after the end of this function. So it's a big no-no. It will return a dangling pointer. And our little crab fairies is like, I'm going to bang on your head. That's not gonna happen. Okay. The problem is that the results go out of scope and gets cleaned up at the end of the longest function. We're also trying to return a reference to result from that function. There's no way we can specify a lifetime parameter that would change the dangling reference, and Rust won't let us create a dangling reference. In this case, the best fix would be to return an own data type rather than a reference, so the calling function is then responsible for cleaning up the value. Ultimately, lifetime syntax is about connecting the lifetimes of various parameters and return values of functions. Once they are connected, Rust has enough information to allow memory save operations and disallow functions and operations that will create dangling pointers or otherwise violate memory safety. What is cargo watch? Does it give me the time? What is the cargo watch? Watches over your project for changes and runs cargo command when they occur. So I don't need to save? Cargo install cargo watch. Ooh, 面白い. So many crates. Yeah, and I like the colorful message. So pretty. 元気ですか?元気です。あなたは? Lifetime Annotation in Struct Definition. Oh, this is what some people has been talking about. Lifetime Annotation in Struct Definition. We're moving to Struct. So far, we have only defined structs to hold owned types. It's possible for struct to hold references, but in that case, we will need to add a lifetime annotation on every reference in struct's definition. Oh, so we can add the reference into structs, but we need to add a lifetime annotation. That's why we were doing the big strings before, and now we can finally have like string slices into the struct as long as we give it a lifetime annotation. Oh yeah. Let's write it. Let's rate it. We have a struct important excerpt, and we give it a lifetime, and we put a sentence in the field and give it a lifetime. Kirana, welcome, hello. You're from English? I'm from Nyansta. It's so fun that people assume I speak Japanese and greet me with Japanese, and I can pretend to be Japanese for like a few minutes for certain people. It feels like life-changing. I know you guys must be having fun just watching me reply to Japanese comment, pretending I understand. It's fun. It's a cute roleplay that I enjoy. Okay. So we have important excerpts. I need to understand how to read it. Excerpt? I read it right. Excerpt. I'm from Nyanstar, the star of cats. Okay, main function. We have a novel, big string. Call me Cyan. Bum bum bum. That first sentence equals to call me Cyan. Yeah. Okay, now we have multiple sentences. First sentence, we are going to do some string processing, huh? Novel does split. We split by the period mark, so it's gonna become call me Cyan, and now, and next, and then expect. What does split return? It's a iterator, that's why we call next. Split is a iterator. Oh, I need to put a message there. It's so nice it wouldn't like give me a message without me typing it. Expect. We here right. The error message could not find a dot. And what's next? So let I equals to important excerpt, and part L. We're instantiating an important excerpt, and with a part with the first sentence. Am I not closing anything? Hello? Oh, wait, what? Where did my stuff go? Okay. And finally, cargo watch and ignore nothing. Ignore nothing. Config as. What is that? What is that? Okay. Cargo was wrong. So what's going on? Oh gosh, is it running by itself? Whatever I do, it just runs by itself. Oh, whoa, fancy. It's like it brings me to the front end time. Every time I just save, I can go check my arrows and my page. Awesome. 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 Okay, so what does this do? This struct have one field, part, that holds a string slice, which is a reference. And as with generic data types, we declare the name of the struct, so we can use lifetime parameter in the body of the struct definition. So we define the lifetime here. We declare the name of the generic lifetime parameter inside angle brackets after the name of the struct. Okay? This annotation means an instance of important excerpts cannot outlive the reference it holds in its part field. So we're saying this I would live shorter or equal than this part field. Oh, so it's saying those two has the same lifetime. You gotta die with me, basically. That's so cool. That's so cool. Can I print it? Like, in line. How do I do that magical formatting? Is that how you do it? I.part? Can I do this? Ooh! Hey! It's saying call me Cyan. Call me baby. Hey, I just meet you. This is crazy, but here's my number. So call me baby. Hey, I'm fancy. And the lifetime of I and the part are the same. Are the same. Yeah, that's the pretty format. I learned stuff from you. But I could just do that. I could just do that. Yeah, you better don't DMCA me. I'll DMCA you. Okay, this lifetime illusion. I tried to Google what the illusion is. The result is surprising. It keeps saying it's like a name. A what? It's not a name? Illusion. The omission of a sound or syllable. So this is like ignoring. Anyways. It was my bad. It keeps Google. It keeps saying it's a last name. I must have typed it wrong. Illusion is basically you don't have to do it yourself in some cases. Whoa, it's automatic. Illusion omission stabilize the wind. What? Lifetime illusion is you not writing the lifetime parameter. Ooh. Let's see how it works. Copy this big chunk. Oh, it's so long. You learn that every reference has a lifetime and you need to specify lifetime parameters for function or struct that use references. However, in chapter 4 we had a function here, which is shown here, that compile with our lifetime annotations. So this is the first word function that finds the first word in a string. And it doesn't have the lifetime annotation problem. It doesn't have lifetime annotation. If 有一天小盐变成白毛，小盐不就变成孤老了？那可不行，那可不行，会被 DMCA 的。不过白毛也很可爱了。Okay, that was a side question. And what do we have here? Why does this thing compile without lifetime annotations? The reason this function compiles without lifetime annotation is historical. In early version of Rust, this code wouldn't have compiled because every reference needed an explicit lifetime. At that time, the function signature would have been written like this. Oh, what? So, at that time, we have to add the tika to everything. After writing a lot of Rust code, the Rust team found that the Rust programmers were entering the same lifetime annotation over and over in particular situations, and it's medokusai. The situations were predictable and followed a few deterministic patterns. The developer programmed these patterns into compiler's code so the borrow checker could infer the times in the situations and wouldn't need explicit annotations. Oh, so after the history, the compiler becomes smarter and we can emit. We can have the emission of the lifetime because this piece of Rust history is relevant because it's possible that more deterministic pattern will emerge and be added to compiler. In the future, even fewer lifetime annotation might be required. The pattern programming the Rust analysis of reference are called lifetime elision rules. They aren't rules for programmers to follow. There are a set of particular cases that compiler will consider, as if your code fits in these cases, you don't need to write the lifetime explicitly. The lifetime elision was derived through Huffman calling? What's Huffman calling again? A particular type of optimal prefix code that's commonly used for lossless data comparison. How does compression has to do with extracting the patterns? What does MFW mean? My face one. There's no way. A compression algorithm can understand emission. Oh wait, it can. They just look at the most frequent patterns and made those implicit ones to delete the most handwritten lifetime possible. It was partially a joke. Optionally, my feelings one. Wait, is it real or is it a joke? Should I trust it? Huffman calling implementation in Rust. Is it? It's a joke, right? It is what it did, but it was manual. Okay. There's so many traps in the programming community. You don't know what is a joke and what isn't until you become a senior. Oh gosh, why are there so many horses in the chat? What does horses has to do with the crabs? Ferris will be stabbed by the horses. Okay, continuing on the elision rules, that was hilarious. The elision rules don't provide for inference. If Ross deterministically apply the rules, but there is still ambiguity as to what lifetimes the reference have, the compiler won't guess what the lifetime of the remaining reference should be. In this case, instead of guessing, the compiler will give you an arrow that you can resolve by adding the lifetime annotation that specify how the reference relate to each other. Lifetimes on function or method parameters are called input lifetimes. And lifetimes on return values are called output lifetimes. Finally, something easy to understand. Rust Analyze will tell your lifetime are redundant. Oh wow. It checks for cleaner code too. Nice. The compiler uses 3 rules to figure out what lifetime references have when they're on explicit annotations. The first rule applies to input lifetimes, and the second and third rule apply to output lifetimes. If the compiler gets to the end of the 3 rules and there's still references for which it can't figure out lifetimes, the compiler will stop with an arrow. The rules apply to function definition as well as implementation blocks. Oh, so we have 3 rules for lifetime elisions. The first rule is that each parameter that is a reference gets its own lifetime parameter. In other words, a function with 1 parameter gets 1 lifetime parameter. So this is a function with 1 parameter gets 1 parameter. A function with 2 parameter gets 2 separate lifetime parameter. So everybody has its own parameter for lifetime. The second rule is if there is exactly 1 input lifetime parameter, that lifetime is assigned to all output lifetime parameter. Wait, what does the rule do? It's used to figure out what lifetimes references have. Figure out what lifetime references have when they are explicit annotations. Oh, so when there's no annotations, here's the 3 rules compiler use to find out the lifetime for the references. The first rule is it gives a separate lifetime for each parameter. And the second rule is if there's 1 input lifetime parameter, the lifetime is assigned to all output lifetime parameters. So here the input is x, which has a tick A lifetime, and then the output is tick A lifetime 2. The third rule is if there are multiple input lifetime parameters, but one of them is self or mod self, because there's a method, the lifetime of self is assigned to all output lifetime parameters. This third rule makes methods so much easier to read and write because fewer symbols are necessary. If there are multiple input lifetime parameters, but one of them is self or mute self because there is a method, the lifetime of self is assigned to all output lifetime parameter. So all the output lifetime parameter will have the same lifetime as self. The third rule makes the method much nicer to read and write because fewer symbols are necessary. So before, when you guys write methods, you have to specify lifetime for all the stuff. That's unbelievable. That's unbelievable. It sounds a lot of work. Let's pretend we're a compiler. We'll apply these rules to figure out what lifetimes of the reference in the signature of first word function are. The signature start without any lifetime associated with the reference. So here we're looking at this. So I think this applies to rule 2. They have the lifetime of the input applies to lifetime of output because there's only one input. Oh, no. Yes? No? Okay, the compiler applies the first rule, which specifies that each parameter gets its own lifetime. So it gets its own lifetime first, and then it goes to the second rule because there's exactly one input lifetime. The second rule specifies that the lifetime of the one input parameter gets assigned to the output. So you figure out the lifetime for this entire function. Not all the references in this function signature have lifetimes, and the compiler can continue its analysis without needing the programmer to annotate the lifetime in this function signature. Okay. Good job, compiler. Let's look at another example. This time using the longest function that has no lifetime. So Ross first give x and y separate lifetimes, tika and tipa. And the second rule doesn't apply because there are more than one input lifetime. And the third rule doesn't apply either because longest is a function rather than a method. So none of the parameters are self. After working through all three rules, we still haven't figured out the return type. So the lifetime of the return type. This is why we got an error trying to compile the code. The compiler worked through the lifetime elation rules but still couldn't figure out all the lifetimes of the reference in the signature. Because the third rule really only applies in method signatures, we'll look at lifetimes in that context next to see why third rule means we don't have to annotate lifetimes in method signature very often. Oh, we're finally moving on to the methods. To the methods. Panic? Who panicked? Who panicked? Lifetime annotation in method definitions. When we implement method on struct with lifetimes, we'll use the same syntax as that of generic type parameters shown, where we decide and use lifetime parameters depends on whether they are related to struct fields or the method parameter and return values. What? Oh, okay. We use the same syntax as of generic type parameter. We declare and use lifetime parameter depends on whether they are related to the struct fields or the method parameter and return values. Lifetime names for struct fields also need to be declared after implement keyword and used after struct name, because the lifetimes are part of the struct type. Like how... Okay, I think we need an example for this. In a method signature implied implementation block, references might be tied to their lifetime of references in Structsville, or they might be independent. In addition, the lifetime illusion rules often make it so that lifetime annotation aren't necessary in method signatures. Let's look at some examples using the struct named important excerpt that we define. First, we'll use a method named level whose only parameter is a reference to self, and those return value is an I32, which is not a reference to anything. Okay, so we have... what do we have? We have our struct with a lifetime tika. And we implement a method. And the only parameter is a reference to self and returns a value I32, which is not a reference to anything. Do we need the lifetime parameter in this case? The lifetime parameter declaration after implement and its use after the type name are required. But we are not required to annotate the lifetime of the reference to self because the first illusion rule. So, after the implement, we need to still have to define the lifetime parameter. But not in the self, because we can use the rule 3, which is saying all the methods has the same lifetime as self. And I think it mentioned that in the implement block, reference might be tied to the lifetime of the references in the struct fields, or they might be independent. So maybe we can use a different lifetime for the methods, as long as it's valid. Okay. Are there still people here? Okay, cool. My chat stopped moving. I was like, oh, what happened? Clara, hello, welcome. Angry? I'm not angry. I'm not an angry cat. What do we have here? What do we have here? Here is an example. The third lifetime illusion will apply. So here, announce and return part. We're using so many stuff. I still have this amount of viewers. I have no idea how many people are here right now. My number shows up as like 0 for some reason. Today maybe the restream API isn't stable. So I don't know how many people are here. More than 2? Happy. 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 Miyuku, welcome. Hello. Thank you. Oh, I don't know. I feel like I just grabbed a bunch of tutors with me. It's just 20 people. There's a lot of people. Welcome. Welcome. Enjoy the rusty journey. What else do I stream? I stream games, drawing, sometimes singing. I'm like a VTuber. I am a VTuber that does VTuber stuff plus coding. That's how I understand myself. I feel like I can write a class about it. I don't know. There needs to be a VTuber class. Anyways. Are there any project I want to try with the language? I'm thinking about it because we tried so hard to learn it. So I feel like we should build something. What's a good project for Rust? Good and fun project. And going back here for the third rule. There are two input lifetimes. So Ross applies the first lifetime illusion rule and give both self and announcement its own lifetime. Or here, self and announcement, they have their own lifetimes. And then, because one of the parameters is self, the return type gets the lifetime of self. Oh, that's how it works. Because there's a self, so the return type is self. Coding is officially part of VTuber stuff now. You need some. Do you need some coding to be a VTuber? Not necessarily, but everything's backed up by a program. I recommend the PNG Me book up if you want something guided. It's written to be done after book. Otherwise, a Discord bolt with Serenity and Poise is fun. Ooh, Discord bolt. We could do one. We have a Discord channel if you guys don't know. Build a web server of CLI Live. Wow. A web server? I think there is a library for a web server in Rust. Build a Cyan AI to do a job for you. My idea for Valentine's Day. I don't know if I'll do something for Valentine's Day. I don't feel like celebrating it. I don't feel like doing the lovey-dovey stuff. But I might be able to get some library and code some stuff that automatically replies to your chat message. Maybe an AI girlfriend POC. I thought that would be fun, but I don't know I can pull it off. Can you see Mel is for a challenger? Last Meow? Meow? Okay. Can we adjust the zoom and data levels? I don't think that library is smart for that. What's the library called? GPL or something? I don't think programming an AI life will be work of one person. I don't think either. So I said it's a POC. If it gives up output for every comment I get extreme, then I'll be satisfied. Okay. Static lifetime. What is static lifetime? One special lifetime we need to discuss is static. Tick static. Which means that this reference can live for the entire duration of the program. Oh, it is the final boss. It lives forever. All string literals have the tick static lifetime, which we can annotate as follows. That S. Wait, what? All string literals has the tick static lifetime, so they live for the entire duration of the program. Is this like a static variable? Thank you, I have finally fulfilled my friend's challenge. Okay, good luck. Aesthetic. Oh, that's how you call it? Aesthetic? Aesthetic? It sounds like a really happy word. Aesthetic? Ecstatic. Ecstatic. Is it really ecstatic? String literals are basically stored in .raw data section of the executable, so you can safely keep references to them forever. Ooh! There's absolutely nothing in common between static variables and aesthetic lifetime. Oh gosh. There's nothing in common. Wait, what is static? Oh yeah. Static is the it's quite different. It's like the class stuff. You create that one static member that belongs to all the instances. So this is quite different from that static. A capital S string has a static lifetime, but it does not live as long as the whole program. It just means it doesn't depend on something else temporarily. Oh. All static variable has static lifetime, but not all static lifetime variable has static scope. So all string literals has the static lifetime. The text of the string is stored directly in the programmer's binary, which is always available. Therefore, the lifetime of all string literal is static. You might see suggestion to use static lifetime in error message, but before specifying static as lifetime for a reference, think about whether the reference you have actually lives the entire lifetime of your program or not. You might consider whether you want it to live that long, even if it could. Most of the time, the problem results from attempting to create a dangling reference or mismatch of available lifetimes. In such cases, the solution is fixing those problems, not specifying the static lifetime. Looks like something you won't do a lot. Because you don't really need to specify static for string. Does it make a difference to specify it or not? This makes Rust compiler sounds like a compiler. It finally starts to suggest you stuff that doesn't really help you. Which seems like a rare case. Like so far, the compiler has been doing really nice to me. A string literal can be static because it's embedded inside the actual application that can never be dropped. But are they born static? Seems so. string literal have static storage duration and thus exist in memory for the rest of the life of the program. You can also store them inside static variables. Ooh. String literals are born static. The read-only data section. Oh. Wow, that's so deep. Knowing all the details of stuff. You guys are amazing. So strings was stored in the read-only data section. Whoa. Strings are like stone, they live forever. Generic type parameters, trait bounds, and lifetimes together. Well, all the monsters are fighting together now. Let's briefly look at the syntax of specifying generic type parameters, trait bounds, and lifetime in all functions. So this is the big boy. What do we have? We first import use display. And here we have a longest with an announcement function. Oh, what? So you can put lifetime and generics in the same angle bracket? That's so cool. And apparently here are the parameters, not the definitions. So one field we have X with a Tika lifetime, a string slice. We have a Y, Tika lifetime, string slice. We have annotation, announcement. Announcement is of type T, and it's an output of a string slice. And here we have a constraint where he has to implement the display. And print line announcement. This is the implementation of the function. And if the length of X is larger than the length of Y, X else Y. Well, what is this? We define a function. With two string and an announcement. We announce something and return X if it is longer, and Y if that's longer. And here's the example. So we have string 1 and string 2. And then we put them into the function with an announcement of type T, which here is a string slice. And the print line, the longest string. Well, I think it says the announcement today is somebody's birthday, and then prints the longest string. It's, in this case, string 1. Ooh, I like this cargo watch. Today is somebody's birthday. The longest string is ABCD. Ooh, we put them all together. Nice job. Nice job. This is the longest function that returns the longer of the two string slices. But here we have an extra parameter and announcement of the generic type T, which can be filled by any type that implements the display trait as specified by the where class. This extra parameter will be printed using this, which is why the display trait bound is necessary. This is a trait bound thing we have to implement the display trait for T. Because lifetime is a type of generic, the declaration of the lifetime parameter tika and generic type T goes into the same list inside the angle brackets of the function name. Ooh, that actually was a little shocking. I thought there would be 2 angle brackets. I don't know if they will be side by side. Fun! Summary. We've covered a lot in this chapter. Now that you know about generic type parameters, traits and trait bounds, and generic lifetime parameters, you are ready to write code without repetition that works in many different situations. Generic type parameters let you apply the code into different types. Traits and trait bounds ensure that even though the types are generic, they'll have the behavior the code needs. You'll learn how to use lifetime annotation to ensure this is flexible code won't have any dangling. To ensure that this flexible code won't have dangling references, and all of this analysis happens at compile time, which doesn't affect runtime performance. Believe it or not, there is much more to learn on the topics we discussed in the chapter. Chapter 17 discusses trait objects, which are another way to use traits. There are also more complex scenarios involving lifetime annotation that you will only need in very advanced scenarios. For those, you should read the Rust reference. But next, you'll learn how to write tests in Rust so you can make sure your code is working the way it should. That is reference, guys. That is reference. Wait, that is not reference. That is lifetime. We finally learned the lifetime. It feels like a lot. Am I going to finish this entire book? It's so long. It's so long. It's gonna take me like 8 more strings. Not 8 more. Look at this smart pointer, it got 6 chapters. How long did it take for you guys to learn Rust? 1 chapter every day? Oh, eventually we will be building a multi-threaded web server. Nice. It gets easier once you get the core concepts done. I hope so. I didn't. I haven't either. Ugh. Also, I skipped chapter 9. If it's not a lot, we can do it right now. How long is chapter 9? What? This is long. Are we gonna panic or not? Cyan, take the challenge. Learn something. Don't be panic. Let's go to chapter 9 and learn the arrow handling. Took me around 3 weeks of doing around 2 to 3 hours per day. Wow. This book only covers the fundamental? Wow. There's not a harder chapter. We just finished the hardest chapter. It took me a couple of months to get familiar with the language. Maybe I will hope I can still use Rust after I'm done with the book. Or secretly writing my resume. I love at C++. That's on my jacket. It may take a few years, but you'll finish it. Dang. Cyan will change her title to Rust VTuber. Pendant equals to can't recover this from this arrow. Result equals to can recover from this arrow. Is that all I need to know for chapter 9? Is that all I need to know for error handling? I started learning Rust like 2 years ago, but I really got into it. I really got it a few months ago after learning more fundamental things like computer memory and stuff. It feels like it deals with memory a lot. Imagine not recovering from panics and telling yourself like good baby. And there's nothing wrong with taking a break from Rust and coming back after break. It's pretty common. In my free time recently, I'm picking up more like the language I've been using, but I never really understood. So I'm like brushing up the basics and stuff. I hope to deeply understand one language and so that it will make it easier to understand other languages. But I do feel Rust is pretty unique. Ever since you learned Rust, it became your primary language for basically everything. Why? Why do you like it that much? But with Rust, excluding the front-end stuff, you can do all the back-end stuffs. Rust is good that it covers basically everything and helps you with many other languages too. The main concepts are in common, I think. You can do front-end stuff in Wasm. What is Wasm? So wait, what? You can build front-end with what? With Rust? WebAssembly? Wasm? What is that? WebAssembly defines a portable binary code format. What? Is that a joke? WebAssembly. Why Rust? Get started. Wait, that's not a joke. When you ship compiled binaries on the web in addition to JavaScript, Rust can be compiled to WebAssembly, which allows you to run it on the web browser. It's ostensibly a faster, thinner replacement for JavaScript. It got a ways to go, but it's promising. What? Non-HTML app in Rust, and you can render the browser, but also in other targets. This is eye-opening, guys. I never thought people can write frontend with Rust. Do they have components and stuff? Props? I am shocked. Fresh application on webpage. Ooh. It's like resembling that? This is eye-opening. This is eye-opening. I didn't know there was such a thing. You guys are so sugoi. Wow. This is so fun. Would this become the next big thing? And I saw you Muhammad in GitHub. Or Yao? Yo? Yo. Yo is named after a certain type of evergreen tree and is pronounced Yo. That's such a good name. WebAssembly client web app framework. Ooh. Oh, cool. Pure Rust full stack Rust app epic. Backend, frontend, everything in Rust. Cargo build, you're done. It sounds tempting. It doesn't support module splitting and the payloads are pretty big. But for example, Rust Dominator has lower RAM usage when doing heavy HTML to modification than best JS frameworks. So there are some wins today. Definitely not for scripting a single menu on a blog at current point. Oh, this is mind-blowing. This is mind-blowing. I should look more into it. This is so fun. This is so fun. Okay, let's start panicking. We have been too chill with all that WebAssembly stuff. Error handling. Rust commitment to reliability extends to error handling. Errors are a fact of life. Errors are a fact of life in software, so Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take action before your code compiles. This requirement makes your program more robust. And there are two categories for Rust errors: recoverable and unrecoverable errors. For recoverable error, we can report the problem to user and retry the operation. Unrecoverable errors are always symptoms of bugs, like trying to access a location beyond the end of an array. Most languages don't distinguish between those two kinds of error and handle both in the same way, using mechanisms such as exceptions. Rust doesn't have exception. Ooh, what do you do, fancy? Instead, it has the type result, TE, for recoverable errors, and the panic, Mako, that stops execution when the program encounters an unrecoverable error. This chapter covers calling panic first, and then talks about returning result values. Additionally, we'll explore consideration when deciding whether or not to try to recover from an error or to stop execution. Okay, let's look more into it. Sayyid Muhammad, thank you for coming. Okay, how do we panic? How do we panic in the right way? Bad thing happens in my code and Rust, and there's nothing you can do about it. In this case, we can use the panic macro. Macro. And hydration check, people drink water. When the panic macro executes, your program will print a failure message, unwind, and clean up the stack and quit. This most commonly occurs when a bug of some kind has been detected and it's not clear to the programmer how to handle the error. By default, when panic occurs, the program starts unwinding, which means Rust walks back up the stack and cleans up the data from each function it encounters. But this walk back and clean up is a lot of work. The alternative is to immediately abort, which ends the program without cleaning up. Memory that the program was using will need to be cleaned up by the operating system. If in your project you need to make the result binary as small as possible, you can switch from unwinding to aborting upon panic. The appropriate section in your Kakotomo file. Oh, so we can change the configuration. When there's a panic, we don't clean up, we just abort. Let's try calling panic in a simple program. What happens? Look at this crap. It's not happy. It panicked as crash and burn. And on the error message it says crash and burn. The line indicated is part of our code, and if we go to that line, we see panic macro. In other cases, the panic call might be in code that we see our code class, and the file name and the line number reported by error message will be someone else's code where the panic macro is called, not the line of your code that eventually led to the panic call. Oh, we can see the line number right here. Ooh. Line number, but you can also, in other cases, if there's other panic, it's gonna be another line. We can use the backtrace function of the panic call to figure out where is the problem. So we can set Rust backtrace equals to 1. Hard go wrong. Oh, and then it traces back. It tells us where the error is from. Oh, Control plus click will lead me to the line. So smart. And also this example is accessing array out of bound, and boom, it's giving me this line for saying, hey, your array is out of bound. In C, if we read beyond the end of a data structure, we'll get buffer overread. So Rust wouldn't let you do it. It's taking you to a panic. Oh, it's taking me to a panic? Where exactly is it? Oh, it's taking me into the panic, like the real panic. In a panic package. All sorts of binaries. Oh, now it has automatic. Yes, automatic backtrace. Nice. Sensei. Okay. Panic, to panic or not to panic. We're not that far yet. We'll be handling recoverable errors with result. So what do we have here? If you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. So that's one case. It's a recoverable error. And we have a result enum that has an OK or error. The T and E are generic type parameters. An arrow has the arrow, OK has the result. Has the stuff we want. Hopefully. Oh, so those are part of the compiler. But I can jump into my code, some standard libraries. Nice. Thank you. So here we're trying to opening a file. Hello. And it returns a result or error. Is it trying to cast it into an integer? This tells us the result type of the file open function is a result. The generic parameter t has been filled in here with the type of the success value. The t is the success value and e is the error. The return type means to call to file open, might succeed and return a file handle that we can read from or write to. The function call also might fail. For example, the file might not exist, or we might not have the permission to access the file. The file open function needs to have a way to tell us whether it succeeded or failed. Okay. In case the open succeed, F will be an instance of OK, and if fails, it will be instance of error. So we can add a match statement to handle the cases. Oh, welcome Adam! Good luck finishing your classes. Do I have an arrow here? Why integer? I don't know. The example wanted to be integer for some reason. Book teaching you to use arrow message to make the compiler tell you the return type. In Rust analysis though, you might just as well hover it to get the necessary information. Look, I can just hover it. Hover. And here is matching F and giving it stuff. Where is my problem opening the file? There needs to be one. Yeah, there's no such file or directory. Is this relative path or absolute path? So if I touch a hello.txt, will you able to read it? I couldn't find it. So did I move this into the source? I just do it over here. No. They're also in the current directory. Okay. But oh gosh. Did I just type ignore what happened. Okay. It should be good now. Please consider why. Yeah, I was confused why you asked for admin. Oops. Okay. Now run something for me. I expect to to be good in the first round. Okay, it's working. Thank you. Hacking into the system root. Yappe. Okay. Anyways, we have the file. Matching on different arrow. What is this? What is this? Okay. Let's try to open the file. And if we can open the file, it's gonna return the file. If not, it's gonna be error. And if it's not fun, you'll create a file. If you can't, you'll say problem creating the file. Otherwise, you'll say problem opening the file. But we do have a file here. So you would say it'll be alright. It'll be all good. But if I delete the file, I should just RM it, right? It won't ask me for sudo. Okay. It will create a new file. Like this. I don't know how you would have arrow creating a file. But if there's an arrow creating file, it will probably say this. And if there's arrow, other kind of arrow that's not fun, you'll say panic. And they make it super hard. When you can only use one line to do all of this. This, right? This is the easiest way of opening a file using the library. And you can even write error message. And it even panics for you. So here. Oh, it panicked, saying failed to open the stuff. Okay. There's also unwrap. What is unwrap? It's a shortcut that's implemented just like match. If the result value is okay, unwrap will return the result value inside okay. If the result is error variant, unwrap will cause panic. Because the panic. But expect let's. It just my OBS just reconnected. Yeah. And welcome Rigo. Hello. Hello. Oh, welcome! The easy way that bubbles the arrow. Function main. Result box dying arrow. What is that? You put a type after the main? What even is that? Oh, the question mark. The return shouldn't matter? And welcome! Ovaro, hello! Hello, Hafnia! You're still watching? You're still watching! You guys still watching? Thank you. What? The question mark handles everything? Can I just delete this? Right? Yes? No? Question mark is like... Oh, so that's why. Because it can only use in this. Okay. Oh. Line is a prefix of a trait object type. So what's wrong? Arrow plus static. How do I return OK? Did I also put it into a box? What is a box? And do I need to have the die? Like... Here? I don't know what I'm doing. Confused me. What is this? In the body? Why? It returns this success value? it returns the failure value. Which is right, because it doesn't have... Hello. Oh gosh, why, Cyan? And... we probably get okay. So we return okay. And if there's arrow, it shows up the arrow. Is that how people usually handle arrow? It's dead. It shows the arrow. No such file or directory. Okay, let's see if the chapter talks about it. I do remember it talks about the question mark. Propagating arrows. Do it. I think. Have we done this? Wow, there's a lot of explanations. What does it want? The question mark operator unwraps the success value, but instead of panicking, returns result arrow from the immediate surrounding function. The question mark helps unwraps. And didn't panic. That's why I can use the arrow, because I made it return a result. Waiting for the hacking into the Pentagon using Rust. I'll get arrested. Love it. Forwarding arrows. What does this do? Where the username from file returns a result. It returns arrow to the calling code using match. So you match OK and arrow into this F, Y. Okay, it has a match. And then a string. And we read into the string. Oh, So we put the file into the string like that. Hello, Hami. Hello, Mysterious K. Welcome. This is so short. Oh, this is talking about the question mark operator. The question mark operator. We use it in here. Oh, it does write okay here. So if I run, what's gonna happen? It looks like this is... We got the result. Actually... Is this how you pipe stuff into a file? No. Wait. How do I pipe stuff into file? No, that's not even called pipe. Okay. Sorry. Okay. Now it's good. So when I run it now, it doesn't really say mail. That was a disappointment. It just returned it. Oh wait. Did they even call it? What? Wait, what? How is this entire thing structured? I'm confused. I need to call it? Like this? Makes sense, makes sense. There's the arrow. Doesn't implement this display. Oh, because this type, it doesn't implement display. Huh? Would this help? Okay. 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 Finally! It mailed! Ah! Oh, stupid kitty. Yosh. So the question mark is defined to work the same way as the match expression. If the value of the result is OK, the value inside OK will get returned from this expression. If it is an arrow, the arrow will be returned from the whole function. So we gotta try if we remove this hello, then what's gonna happen, baby? It's gonna print an arrow? Yeah, it print an arrow. OS arrow. File not found. 楽しみ。No crash this time. Not panic. Happy. Happy. I recovered by not unwrapping. No panic, only come. I will come, Neko. What is this? Changing the method immediately. Ooh, you can do this. You just put a question mark to handle the arrows. God, arrow handling is so easy in Rust. You just crashing it. It doesn't panic you. It just gracefully return you an arrow. Ooh. Like. Is this an even shorter function to do all of the thing we just did? Did it implement? Oh, that's no problem. It doesn't. Okay, I need to. It needs to be called. Probably will show me an arrow. Yes, sir. It shows an arrow. Nice. The question mark operator can only be used in functions that have return type compatible with the value question mark is used on. This is because the question mark operator is defined to perform an early return of the value out of the function, in the same manner as the match expression we defined. The match was using a result value and early return arm return an arrow. The return type of the function has to be a result to be compatible with this return. So if we don't return and we put a question mark in there, it's going to get us an arrow. What arrow is it? Cannot use the question mark operator in a function that returns nothing. This function should return result or option to accept question mark. So we are only allowed to use question mark if we have result option. or another type that increments from residual. So I gotta put that result on there. Yes, gotta make the result type right. Oh, this is the thing that was confused me. That made me confused before. What is this box thing arrow? It's called a trait object, which we'll talk about in using trait object that allows. Okay, it's a trait object in chapter 17. Any kind of arrow. So this is any kind of arrow. Using a question mark on result value in a main function with this return type is allowed, because now an arrow value can be returned early. When a main function returns a result, the executable will exit with a value of 0 if the main function returns OK, and will exit and will exit with a non-zero if the main arrow returns an arrow value. A box is a pointer to the hip, so creating a boxed value is just putting it on the hip and getting the pointer back. Oh, I like a box though. A pointer type for hip allocation. Whoa. I wanna read chapter 17 at some point. Looks like a lot of stuff is going on there. To panic or not to panic? When you choose to return a result value, you give the calling code options rather than making a decision for it. The calling code could choose to attempt to recover in a way that's appropriate for its situation, or it could decide that an error value in this case is unrecoverable, so it can call panic and turn your recoverable error into an unrecoverable one. Therefore, returning result is a good default choice when you are defining a function that might fail. In rare situations, it's more appropriate to write code that panics instead of returning a result. So usually we default to return result instead of code panic. So those are for prototyping, unwrap and inspect. If a method call fails in a test, you want the whole test to fail, even if that method isn't a functionality under test. Because panic is how a test is marked as a failure, calling unwrap or inspect is exactly what should happen. So unwrap and inspect are used for testing. Do we have a room of spammer coming through? Let me go to my YouTube. So many spinners. Thank you, Ice Cat. Chat delay. What is a chat delay? Oh, what? I never knew we can do that. I thought I can bang it from a restring, but it seems like I didn't do. I'm not able to ban it. Some people use chat delay to see my latency. Did I bad? Okay. Cases in which you have more information than the compiler. It will also be appropriate to call unwrap when you have some other logic that ensures the result will have an OK value. But the logic isn't something compiler understands. You still have a result value that you need to handle. Whatever operation you are calling still have the possibility of failing in general, even though it's logically impossible in your particular situation. If you can ensure by manually inspecting the code that you'll never have an error variant, it's perfectly acceptable to call unwrapped. Oh, so you're saying there won't be an error. So you can directly unwrap it. We are creating an IP address instance by parsing a hard-coded string. It's acceptable for use unwrap. Having a hard-coded value string doesn't change the return type of the parse method. We'll still get a result value, and the compiler will still make us handle the result as if the error variant is a possibility, because the compiler isn't smart enough to see that the string is always a valid IP address. If the IP address string came from a user, rather than being hard-coded in the program, and therefore it did have a possibility of failure, we definitely want to handle the result in a more robust way. Okay. Guidelines for error handling. Guidelines for error handling. It's advisable to have your code panic when it's possible that your code could end up in a bad state. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid values, contradictory values, or missing values are passed to your code. Plus one or more of the following. The bad state is something that's unexpected, as opposed to something that will likely happen occasionally. Your code after this point needs to rely on not being in this bad state. There's no good way to encode this information in the types you use. If somebody calls your code and passes the value that doesn't make sense, the best choice might be called panic and alert the person using your library to the bug in their code so they can fix it during development. Similarly, panic is often appropriate if you're calling external code that is out of your control and returns an invalid state that you have no way of fixing. However, when failure is expected, it's more appropriate to return a result than to make a pending call. A parser being given malformed data or HTTP request returning a status that indicates you have hit a rate limit. In these cases, returning a result indicates that the failure is an expected possibility that the calling code must decide how to handle. I'm panicking all the time. What is finger calls? Don't panic. Calm down. Calm down. When your code performs operation on values, your code should verify the values are valid first and panic if the values aren't valid. This is mostly for safety reasons. Attempting to operate on invalid data can expose your code to vulnerabilities. This is the main reason the standard library will call panic if you attempt an out-of-bounds memory access. Trying to access memory that doesn't belong to the current data structure is a common security problem. Functions often have constructs. Their behavior is only guaranteed if the input meets particular requirement. Panicking when a contract is violated makes sense because a contract violation always indicates a caller-side bug and is not the kind of error you want the coding code to have explicitly handled. There's no reasonable way for calling code to recover. The calling programmer needs to fix the code. Contracts for a function, especially when violation will cause a pending, should be explained in the API document for the function. Oh, I'm finally seeing some explanation on the panics. What's going on in the chat? What are their horse and fingers? Yeah? We can create custom type for validation. Oh, so here we pause it as an integer. Is i32 positive? It doesn't have to be positive, right? Wait. Thank you for subscribing. Oh no, Noki. Welcome. Find the integer. Let's answer an integer. The non-unsigned integer has a sign. Oh, it has a sign. Oh, it made a new type. Instead of checking the number between 1 and 100 here, it made a type. It's safe for functions to use the new type in their signature and confidently use the value they receive. It will only create an instance of guess if the new function receives a value between 1 and 100. Oh, so we have a struct of guess. And we're initializing it if it's not in the range with panic. And if it's in the range, we'll initialize it. So you can use the new type in the signatures and use the value they receive. We implement a method named value that borrows self, a value that borrows self, and return the value. It's a getter, yes? It's important that the value field to be private, so the code using the guess struct is not allowed to set the value directly. Oh, okay, getter and setters. A function that has a parameter or returns only number. A function that has a parameter or returns only number between 1 and 100 could then declare in its signature that it takes or returns a guess rather than an I32, and wouldn't need to do any additional checks in its body. Okay, that's some thinking. Okay, end of the chapter. Rust error handling features are designed to help you write more robust code. The panic macro signals that the program is in a state that it can handle and lets you tell the process to stop instead of trying to proceed with invalid or incorrect values. The result enum uses Rust type system to indicate that the operation might fail in a way that your code could recover from. You can use result to tell the code that tells your code. You can use the result to tell your code that tells your code that it needs to handle potential success or failure as well. Using panic and result in appropriate situation will make your code more reliable in the face of inevitable programs. Okay, that is the error handling. Now I won't be very confused if I see this box, this hip pointer. No more chapters, time to sleep, yes. I'm so ready to get some food and nurture my brain a little bit after reading those chapters. Thanks guys for coming and having fun. We learned about error handling and lifetimes. And also web assembly stuff. We learned that Rust is very powerful. And Lifetime is more intuitive than I said. Not the endurance, it's been 3 hours. My brain's gonna become a fry egg. Thank you guys for coming. My next stream is gonna be Sunday morning. I'll be watching Ponyong. The Ghibli movie. The Goldfish Princess. If you guys want to watch along, please join my membership. And we have our Discord at cyan.com/discord. And see you guys on Sunday. Thank you for coming. Thank you for teaching me. Hope you guys never write any books. Bye bye. Thank you, Mixis3K. Thank you, Spraga. Thank you, Batomi. Yes, this is the end. Humanity will fall apart from this point on. Boom. That. Bye bye，诸位，谢谢 ，Thank you， 谢谢冰妈，好好休息，辛苦啦 ，See you later 啊 ，Thank you Clara，Thank you Evan，Thank you so much， ありがとう ，Thank you for teaching， 谢谢 ，Thank you Thank you Overall， 继续。Thank you Anden，Thank you Adam。Thank you, Kila Nasu of Horizon. 再见, bye bye. Never write any books. Never. See you guys later. Bye Sebastian, bye Frank. You're an active person. Charge your stuff. I'll use something healthy. Bye bye.